Welcome to Do the Math America. I am Charlene, Math Shaman. Beginning this lesson 48 and for the next several lessons, I will be using New Elementary Mathematics Syllabus D to introduce you to geometry. You may purchase a copy of this textbook from singaporemath.com. I do not receive financial compensation for my recommendation. In this video lesson, I will animate the examples from pages 230 to 236. We will be discussing line segment, line, and angles, how to properly label angles, and how to use a protractor to measure angles, and finally, how to use a compass to bisect an angle. When we bisect an angle, we divide it into two equal halves. If we mark 2 points and join them with a straight edge, we have a line segment. The 2 points we marked are called endpoints. If we name these 2 points A and B, we get a line segment. The ruler is used for measuring length and drawing line segments. The measurement of length should start from the mark 0 on the ruler. Always be sure to indicate the unit of measurement, whether it's centimeters or inches, etc. This particular segment I am demonstrating measures out to be 10.3 centimeters. If we extend the line segments in both directions, on and on without end, we will have what we call in geometry a line. A line AB may be represented like this. Line segment AB, line AB, or the length of AB may be simply written as AB. A line that is drawn perpendicular to another line is called a right angle. Right angles measure out to be 90 degrees. A right angle is usually marked with a small square corner and is notated as 90 degrees. The little tiny circle written to the upper right of the number is the degree sign. This figure I am drawing is called an angle. The point of the angle is called the vertex. Lines AB and AC are called the sides or arms of the angle. We name this angle as angle BAC or angle CAB and write it as BAC with a little hat on top of the A, or as CAB with a little hat on the top of the A. Or we can also write it as angle BAC or angle CAB, with a tiny angle in front of either to indicate that it is an angle. Notice that when naming an angle, we always put the letter for the vertex in the middle. Another way of indicating an angle is shown where we use a letter of the alphabet next to the curved line indicating the angle. In this case, we notate this as angle P with the hat written on top of the P. There are 3 types of angles. 1, an acute angle, which is less than 90 degrees. 2, an obtuse angle, which is greater than 90 degrees, but less than 180 degrees. 180 degrees is a straight line. And 3, a reflex angle, which is greater than 180 degrees, but less than 360 degrees. 360 degrees is a full circle. We distinguish this third angle as a reflex angle as opposed to an acute angle by drawing the scoop around the outside of the vertex. Here I label the 3 types of angles: the acute angle, which is less than 90 degrees, the obtuse angle, which is greater than 90 degrees, but less than 180 degrees, a straight line, and then the reflex angle, which is greater than 180 but less than 360 degrees. And here I draw out a 90-degree angle or a right angle for reference, and a straight line, 180 degrees, and 360 degrees to show you as a reference. Two angles are said to be supplementary if their sum is 180 degrees. So here I show you an angle that is 33 degrees right next to an angle that is 147 degrees, and those add up to 180 degrees, so therefore they are supplementary. And here is another example of two angles not attached to each other. One is 45 degrees and the other is 135 degrees. And those two angles add up to 180. Thus, they are also supplementary. Two angles are said to be complementary if their sum is 90 degrees. So here I draw you a right angle because that is 90 degrees. And if I draw a line through the vertex of this 90-degree angle, I will create two smaller angles, and those are complementary. In this case, the smaller angle is 24 degrees and the larger one is 66 degrees. 66 plus 24 add up to 90 degrees, so these are complementary angles. Two angles, if they are not attached to each other and they add up to 90 degrees, are also complementary, as in these two angles. The angle on the left is 33 degrees and on the right is 57 degrees. 33 plus 57 equals 90. Those angles are complementary. We use a protractor to measure the size of an angle. The protractor is a semicircle. The center of the circle is the midpoint of the baseline. To measure an angle, you follow these steps. Number 1, place the center point of the protractor on the vertex of the angle to be measured. 2, align the baseline of the protractor with one arm of the angle. 3, read the appropriate scale, that is, the scale that starts with 0 from the aligned arm. Here I've drawn out 3 angles for you and labeled them each. I like to label the angles before I measure them. Angle ABC is an acute angle. It will measure less than 90 degrees. Angle DEF is a right angle. It should measure 90 degrees. Angle XYZ is an obtuse angle. It will be greater than 90 degrees. So when I read the scale of the protractor, I will be looking at the numbers according to whether it's greater than 90 degrees or less than 90 degrees. So I make sure to put the center point of the protractor on the vertex of the angle to be measured. Angle ABC is less than 90 degrees. I will use the scale on the protractor that is less than 90 degrees. I read carefully where the arm of the angle crosses the scale on the protractor, and I see it is 43 degrees. I write that down next to angle ABC. Angle DEF is 90 degrees, and I confirm that on my protractor. It's 90 degrees. I write that down next to angle DEF. Angle XYZ is an obtuse angle greater than 90 degrees. So I look on my protractor scale and look at the numbers that are greater than 90 degrees, and I see that it is 125 degrees. I write that next to the angle. Next, I will show you how to use the protractor to draw out an angle that is 45 degrees. So I start by drawing out a line segment, and then I match up my protractor center point to the end point of that line segment, and I mark on the paper or on the board here where 45 degrees hits next to the protractor on the board. And that point will be where I will draw the line through the next arm of the angle, matching the endpoint to the mark on the board. And that will be the angle at 45 degrees. Next, I will demonstrate how to draw out an obtuse angle of 120 degrees. Once again, I start by drawing the line segment, and from the endpoint, I will match up the center point of the protractor, lining up the line of the center point of the protractor with the set line segment itself. I look beyond 90 degrees and find 120 degrees on the protractor. I mark the point right next to that on my board, and then I use the endpoint and draw a line through that mark, 120 degrees, and then this is my 120 degree angle. And here I will demonstrate a few more examples of how to line up the protractor with various angles. And again, you just need to keep in mind that if an angle is an acute angle, less than 90 degrees, you read the scale on the protractor that is less than 90 degrees. In this example, the angle opens to the left, and you can use your protractor as long as you line up the center point to the vertex of the angle and read on the protractor scale where the side crosses. And in this case, it's 58 degrees. With this obtuse angle, you match up the vertex to the center point of the protractor and read on the scale that the number that is greater than 90 degrees. The 137 degree angle, you will have to count out the markings on the protractor scale to get that reading. This next example has an angle with a short arm, too short to cross the protractor scale in such a way that you can get an accurate reading of its angle. So you need to extend that arm by using a straight edge and making it a longer arm so that you can see where the arm will cross the protractor at the scale. And once you line up the baseline to the center point of the protractor, you can count out those gradations on the protractor scale where the arm of the angle crosses to get an accurate reading. Sometimes, as you can see, it takes a little bit of time and practice. You do need to be somewhat careful to get an accurate reading on your protractor. This next figure, I will demonstrate how to measure the angles. There are multiple angles on this figure, and I start by notating the angle to be measured. Remember, we always put the letter for the vertex in the middle. So I'm first measuring angle QPS, putting the center point of the protractor on the vertex of the angle. I marked the angle itself as well as the notated angle, and I do that for each of the three angles. All three of these angles listed are under 90 degrees. They are all acute angles. For an acute angle like this one, if you find yourself reading on the protractor scale larger than 90 degrees, then you know you've read the wrong scale. As you can see, it takes patience and time to read a protractor correctly. If you rush, you might make a mistake. These three angles form to make a straight line, so they will add up to 180 degrees, you will find, after you take your measurements. An angle of 70 degrees plus 40 degrees plus 70 degrees does add up to 180 degrees. They are therefore supplementary, just as the figure shows. The following figures are from page 236 of the textbook. The exercise directs us to measure all angles marked with letters, then name all pairs of complementary angles, all pairs of supplementary angles, and all pairs of equal angles. As you study geometry, you will find it is difficult to reproduce figures precisely when you draw them out on your own, sometimes because your pencil lead is too thick to allow you to reproduce the precise angles. So you will get better measurements by using the figure directly from the page of the book. However, these figures are small enough that your protractor cannot catch the sides of the angles on the scale. If you try to get perfect measurements on this exercise, you will be frustrated, as it's almost impossible with most school grade plastic protractors. With an exercise like this one, I suggest you use a straight edge and make a rough copy of the figures. Make sure you label with all the same letters and markings, and then use your protractor to measure the angles as best you can from the book, and then record those measurements on the figure that you have reproduced on your page. Please take the time to do these exercises. Geometry is a study of shapes and angles and the properties of those shapes and angles, and this exercise will allow you to see some patterns when it comes to angles and their relationships with each other, complementary and supplementary angles, and angles which are equal in measurements. I will demonstrate the first example, 2A, finding all pairs of complementary angles, all pairs of supplementary angles, and all pairs of equal angles. First, I will measure each angle and label them. Then I will list all pairs of supplementary angles. A reminder, supplementary angles add up to 180. 180 degrees is a straight line, so I start by identifying the pairs of angles that are along a straight line. The first ones I see are angles A and B. I begin my list of supplementary angles by writing A and B. Next, I see that angles F and E are also along a straight line, and I add F and E on my list of supplementary angles. Looking the other direction, I see that angles F and A are also on a straight line and are also supplementary, as their angles 60 plus 120 add up to 180. I continue on my list writing A and F. On the other side of A and F are angles B and E, also along the straight line. I add B and E on my list. Angles can be supplementary without being adjacent. Adjacent is a term frequently used in geometry. It means next to. Angles can be supplementary without being adjacent. In other words, they don't have to be right next to each other. Just have to make sure that their sum is 180. With that in mind, I see that angles A and angle D add up to 180, and I add those to my list. Along that same train of thought, I see that angles E and D are also supplementary, and I write those on my list as well. Now that I found all my supplementary angles, I am ready to hunt down the complementary angles. Complementary angles make up a right angle, or they add up to 90 degrees. Please make note of how complementary is spelled, complementary. I trigger my memory that it's spelled with an E by thinking of it as a complete angle, not complementary, as in I like your hair with the I in the middle. Okay, so back to our complementary angles. The first ones I see are angles C and D. They make up that right angle. And 30 plus 60 equals 90. The non-adjacent complementary angles includes angles F and C, as they also add up to 90 degrees, and I include that on my list as well of complementary pairs of angles. As I was recording this video segment, I missed the third pair of complementary angles, angles B and C. I will mark those later in the video. Moving on to list the pairs of equal angles, I begin by noticing that angles F and B are both 60 degrees. They are equal. They are also across each other on an X, or opposite angles. Angles A and E are both 120 degrees and also opposite angles. Angles B and D are both 60 degrees, so they are equal angles, and I write those on the list as well. The other pair of equal angles is angles F and angle D, both 60 degrees. And I include angles F and D on my equal angles list. As I peruse my lists of supplementary, complementary, and equal angles to see if I've missed anything, I see that I did miss angles B and C as being complementary angles, so I add those to my list of complementary angles. This next exercise directs us to measure angle ABC and draw an angle XYZ such that XYZ equals 1/2 of ABC. I begin by measuring angle ABC with my protractor, and I find that it is 25 degrees. Write that down next to the angle. Next, I need to do a little math. XYZ needs to be 1/2 of ABC, so I need to figure out what is 1/2 of 25 degrees. So I need to solve the problem 1/2 times 25. I multiply this out as a fraction, 1/2 times 25 over 1, multiplying the numerators across and the denominators across, which gives me 25 over 2. 25 over 2 is a division problem. 25 divided by 2, and I do that division problem on the side, and I figure out that it is 12.5. So now I need to produce an angle that is 12.5 degrees. My protractor does not allow me to make measurements of such precision, so I will do the best I can. I draw out a separate angle with 12.5 degrees, or I can bisect this one, drawing a line right down the middle of angles ABC. And in this case, I start my drawing and I find that it goes off course because my straight edge is not long enough and my erasing job is not very thorough either. So I use a longer straight edge and I struggle to get this drawn well. I finally managed to produce a line through the middle of ABC, and I will label that angle as XYZ. Notice that I can use either the sides of AB or CB to relabel as X. Both of those angles are 12.5 degrees approximately. But now I will show you how to use a compass to bisect an angle. A compass is a tool to draw circles. There is a point on one side of the compass and a lead piece on the other side used for drawing the circle. The point will be the center of the circle, which you use to stab into the middle of your paper, and then you swing the arm around with the lead to produce the circle, as I demonstrate now. You can widen the arms of the compass to produce a larger circle. The distance between the point of the compass and the lead of the compass will be the radius of the circle, or the halfway point. I will discuss that in greater detail in future lessons. You can see that by widening the arms of the compass, I produce a larger circle. You can produce a perfect circle with the compass as long as you make sure to keep the center point fixed in one spot. Now I will show you how to use a compass to bisect angle ABC. First, you fix the point of the compass onto the vertex of the angle, and then you swing the compass around so that the lead makes a cross on each of the arms of the angle, and then you use the point of the compass at that X point on each of the arms of the angle and draw 2 arcs in the middle of the opening of the angle so that they cross. That is the point at which you line up your vertex to the X of the arcs, and that is your middle point of your bisector, the line that will divide the angle in half. And that is how you can use a compass to bisect an angle. And I use the protractor to verify the measurements as closely as I can. The exercises for this lesson are found on pages 237 and 238. Please do as many problems as you need in order to get a firm grasp of this material. And please check your answers with those in the back of the book to make sure you did the problems correctly. I hope you found this video helpful. Thank you for joining me at Do the Math America.